vectors. With respect to origin O, we have point A, point B, and line equation L, acute angle between the directions of. Okay, so we have this MF19 formula for vectors. This is the dot product formula. So if you rearrange this formula, you're gonna get A dot B divided by magnitude of A, magnitude of B. So if you just divide both sides by the magnitudes of A, magnitudes of B. Okay, so this is the form we're gonna use. So since this is between AB and L, we're gonna need to find the factor AB, and we use the direction of L. So for the factor AB, that will be the coordinates of B minus the coordinates of A. So this guy minus this guy, 3 minus 1, and so on. So this is the AB factor. And for the L, we are using the line direction. So the one with the lambda is the line direction, and this is the point on the line, a random point on the line, and the line direction. Okay, so since we are looking for the acute angle, you see here acute, actually we need to use something positive for the inverse cos. So you can use the absolute value to make sure it's positive. Okay, otherwise you're gonna get the second quadrant obtuse angle if it's negative, but actually in this case it's positive, so there's no need to use the absolute value actually. Okay, so for the dot product, we multiply corresponding components. So the x component 2 times 1, the y component, and so on, we multiply and then add everything. This is the dot product. And for the magnitudes, we use like Pythagoras, square root of the square of each component, and then you add everything. Okay, so 2 squared minus 1 squared minus 3 squared, and so on. Okay, we have the magnitudes, and then use a calculator, we get this. And remember, this is still cos theta, not theta, so we still have to use inverse cos, and we get the angle. And next part, find the position factor of the point P on line L such that. Okay, so in the previous part we know the point A, point B, line L. So just start by drawing a sketch. Let's say this is the line L, this is the line equation, and the point P is on the line. We don't know the coordinates, so let's just call it x, y, z. And for the point A and point B, let's just say it's here and here. We know that this length AP is the same as the length BP. So for the length AP, we need the factor AP. So the factor AP is P minus A, the coordinates of P minus the coordinates of A. So this is the factor AP. For BP, that's going to be P minus B. So we have AP, we have BP. And as you can see, we have an equation in 3 variables, x, y, z. There's nothing we can do here. So we're going to use the fact that this point P lies on the line, which means the x, y, z satisfy this equation here, which means we can replace the x with 2 plus lambda. We can replace the y with 3 minus 2 lambda, and the z with 1 plus lambda. So that's what we do here. We replace the x, y, z, and then we simplify everything. Now everything's in terms of lambda. We can find lambda. So if we simplify, we have 2 plus lambda minus 1. So that's just 1 plus lambda. And minus 2, so 1 minus 2 lambda. 1 minus 1 is 0, so just lambda. And same thing here, we simplify 2 plus lambda minus 3, so that's lambda minus 1. And this is minus 2 lambda plus 2, and this is 1 plus 2, so 3. 1 minus 2, yeah, actually this is 3 plus 3, lambda plus 3. Okay, so now we use the magnitude formula, so the square root of the sum of the square of each component. So this squared, this squared, this squared, add everything. Same thing on the right. Okay, so now we square both sides, so we cancel out the square root, and then when we expand this, just do it like this. So for the 1 plus lambda all squared, we get this 1 minus 2 lambda all squared and lambda squared. Same thing on the right, just expand like this, and so we can add everything easily. From here we have 1 plus 1 is 2, this is minus 2, and this is 6. This would be 14, and this is minus 4, and this is 6. We cancel out, and we can add 4 lambda to both sides, so we have just 2 lambda on the left, and we subtract 2 from both sides, so we have only 12 on the right, which means we divide by 2, we get lambda equals 6. After we have lambda, we can plug into the line equation to find the coordinates of P. And what we are looking for, okay, we are looking for the coordinates of P, so this is the final answer. All right, I'll see you